Welcome back. In this video, we will learn how to insert item into queue. To recap, a queue is a linear structure in which items may be added at one end while removed from the other. There are two operations here. The first one is insertion operation, where it will ask what to insert, but you should not ask where to insert, because the new data will be always added after the last element in the queue. In case of deletion operation, you should not ask what to delete and from where to delete. In queue, whichever goes in first will come out first. So this is FIFO, that is first in, first out. A demo of insertion operation will be here. Now there will be two variables, front and rear. Front will hold the index of the first element, and rear will hold the index of the last element in the queue. If initially the queue is empty, then set front and rear to 0th index and place 44 over there. Now for 55, you increment rear by 1 and then place 55 at the index 1, because rear is standing at index 1. Now for 33, you increment rear by 1 again, so that rear will be standing at index 2 and place 33 over there. For 77, rear will be at 3, for 22, rear will be at 4, and for 66, rear will be at 5. So please notice that during insertion, rear is acting as a guide to the new data for finding the proper place in this queue. During deletion, you just increment front by 1. Initially, when front was there, your queue was starting from this place, that is index 0, and it was ending at index 5. When you perform the deletion operation, front will be standing now at 1, so that your queue will be starting from here and will be ending here. Further operation you do, the front goes to index 2, so that your queue will be starting from here and ending over here. In this way, you can increment front by 1 and it will be considered as a deletion operation. The data, of course, will be there inside these cells, but these data are invalid because front is standing at 5 now and rear is also standing at 5. Now one thing you should notice that whenever you will find that front and rear is standing on the same index as it is now, then you should know that there is only one element. When you will see that front and rear, both of them are standing here at -1, then you should know that the queue is empty. Now let us look at this algorithm for insertion in queue. This is the name of the function queueInsert, and it is taking 5 parameters. The first parameter is queue, and it's an array. The second one is n, which is the size of the queue and which is also the last index of the queue. Front is there, which is holding the index of the first element. Rear is holding the index of the last element. And item will hold the new data which is to be inserted inside this queue. Now here we'll see that there are 3 major steps here. The first one is checking whether queue is full or not. The second step is finding the new value of rear, because rear will show the new data where to be placed. After this, the item will be inserted in that location where rear is standing. Let us write the code over here. The name of the function is queueInsert, as it is written in this algo. Now the first parameter is queue, is an array. The second parameter is n. The third parameter is int star front. We have taken pointer variable here because the original front, which is controlling the first element, will be there inside the main function. So from this function, we will control the front variable inside main. That is why we have taken front pointer here. A similar case goes with this pointer variable, that is rear. So originally the rear will be there inside main, So we will control the rear's values from here with the help of this pointer variable. And the fifth parameter will be item. It's an int variable. The data from the item inside main function will be copied to this item variable. Now we move to first step. In the first step, there are two conditions by which you will know that your queue is full. The first condition is if you find that front is 1 and rear is n. You see the figure? Front is at the first index and the rear is at the last index. Here, of course, our programming language considers first index as 0 and the last index as n-1, that is 5, because here n is 6. So whenever algo says front is 1, we say front is 0. And whenever algo says rear is n, we say rear is n-1, right? So from the figure you can see that front is standing at the first index, that is 0th cell, and rear is standing at the last index, that is the 5th cell. So it is clear that the queue is full. There is another condition by which we will come to know that the queue is full. That is, front is rear plus 1. That means rear is preceding front. How it goes like this? Let us see this example. Suppose front is standing at index 2 and rear is standing at index 4. Now before this, you may ask me that how front is here? Front should be at the 0th index. Yes, front was there initially at 0. But due to 2 times deletion operations, front has come down to 2. So, what you should do to insert a new item? Of course, you increment rear plus 1 and put 77 over there. Now you see that rear is standing at the last index. So there is no vacancy afterwards because the array ends here. But there are vacancies at the 0th index and the first index. So of course you bring rear from the 5th cell to the 0th cell and put 22 over there. Please remember this operation, that whenever rear will be at the last index and if there is vacancy in the first index, then you can bring the rear from the last index to the first index to insert the new data. Next, there is still one more vacancy to insert 66. So increment rear and put 66 over there. Now you see that the queue is full. And also you notice that rear is preceding front, as it has been mentioned in this algorithm. So if these conditions are met, then you will know that the queue is full and write overflow and return. Now we write the code. If star front is 0 and star rear is n-1, or the second condition, that is star front is star rear plus 1, then you give the message overflow and return from this function at once. If this if condition fails, it signifies that there is at least one vacancy in this queue. Then you go to step 2 to find the new value of rear. There may be 3 situations for finding the rear's new value. First, if front is null. So in our situation, the front will be -1. And of course, rear will be -1. And if you see this, then to find out the rear's new value, you should increment rear by 1 and front by 1. So the algorithm says set front to 1 and rear to 1. So you write if star front is -1, then we will do star front equal to star rear equal to 0, because this is our first cell. We move to the else if part. It says that if rear is n. Now the situation will be front is not null and rear is n, right? That means front is somewhere, say at index 2, and rear is at the last index, that is index 5. So if this is the situation, then what to do? You already know that in this kind of situation, you bring the rear to the first index and put the new data over there, right? The algo says set rear to 1 and we set rear to 0. The code will be like this. Star rear is n minus 1. Then you set star rear to 0. Now we go to the else part. The else part says that front is not null and rear also is not n. That means front is somewhere here and rear is somewhere here, which is not the last index. In this kind of situation, you simply increment rear by 1. So the algo says that set rear to rear plus 1. So in our code, we write else star rear equal to star rear plus 1. Now we have got the rear's index. We move to step 3. Set q rear to item. So we write q star rear equal to item. Now we bring main here. We have this prototype. There is a first parameter is q, it's an array, so we have written int star. The second parameter is n, the size of the array, so we have written int. The third one is the front pointer, so int star. This is the rear pointer, int star, and this is the item variable, that is int. Next, we declare q array with the size 6. N is 6. Front is set to -1. Rear is also set to -1. Item will be there, which will be loaded with new data. And there's a con variable, which will decide whether you would like to continue the insertion operation or not. You read data inside the item variable. Then you move inside the do while loop. And you call the QInsert function with these parameters. You send the address of q to the q array over there. You send the data of n to the n variable. Then you send the address of the front here to the front pointer over there. Send the address of rear to the rear pointer. And send the items data to the item variable inside this parameter. After sending this, it will decide the new index of the rear and it will put the item in that new rear's index. So your queue will be updated with the new data. Next, you go for asking whether the user wants to continue the operation or not. So if con is 1, then it will move back and the while loop goes on. Now, of course, if the array is over, then this condition will fire. This is the first if condition, and it will print overflow and return from this function. So you don't have to worry about the overflow condition because it has been already checked. I hope it's clear to you how to insert item in a queue using algorithm like this and using the C language. In the next video, I will show you how to delete item from queue. Thank you for watching and take care.